So now we're going to look at sections 10.4 and 10.5, and a lot of this you're familiar with, but I need to say something about notation. So for the voltage, for example, for V plus, we had something like F1 of T minus Z over V. Now it's finally time to figure out what the F is going to be. Well, guess what? Something you're all really familiar with. Sine or cosine, say let's take cosine and exponential. So choices for F, cosine, or EXP. So one of the things that's really a bit complicated is notation in textbooks. So he has 3 different ways of writing all this stuff, the 2 authors. So is script V of Z, and they use Z rather than we used X before, instantaneous. So it's the real instantaneous voltage, and it looks something like this. 1/2 of a complex amplitude and this is referred to V naught. This whole term here, e to the plus or minus j beta z times e to the j omega t plus the complex conjugate. So if we call this whole thing B, then this is going to be B star. In the book it's not clear because it says CC and it's kind of gone over real quick, but you'll recognize this as the real part of this complex exponential. So if we want to write it as a complex number, then it's going to be, complex is going to be VC, and the V is given in italics here in the book, is V0, so that's the complete complex amplitude. And I'll leave it for you to figure out what the phasor version is. Vs of Z and T equals. So I think we all know what the phasor version is. We leave out the e to the j omega t. Final note is, you see this, the form of this function. So for example, e.g. here, supposing we look at this, e to the minus j beta z, e to the j omega t, factor out the j and you can see that this is of the form e to the minus j beta z minus omega t. And this is definitely of the form, if I divide by beta, or if I divide by beta, you see we get omega over beta, it's z minus vt, with the beta out as a scale factor. So this is the right form of a wave traveling to the right, and we're going to do a lot of work with these formulations in interpreting what happens on the lines for different loads at different configurations.